Yes, hi everyone. My name is Faraji and welcome to my data visualization project. And today project, I'm trying to answer the question that how does the mammal sleep differently? So I have used the AMS data from the ARA package, and this data contain over 83 different species of mammal. And the core today is to analyze how the environmental factors like the body weight, the diet, and also the environmental conservation status affect the sleeping behavior or the rapid eye movement of this mammal species. And to explain my analysis results, I have created the dashboard in order to explain the visualization. So before diving into the distribution, I have created the schema, which shows some of the outliers of this animal in our dataset. And then starting with the 15 most sleepiest animal. As we can see here in the chart, we have animal like little brown bat, which have a average sleep hour of about 20 hours. And we always know that animals like little brown bat, they are very small in size. And so let's move to the 15 list sleep animal. For this case here, we can see animal like giraffe at the bottom here. They have a sleep hour of less than 2 hours, and this tells us a story. And they belong to the species which is herbivorous. The same to the parrot wild, which are carnivorous. They have also shown to have the least sleep hours of less than 3 hours, I can say. Also, to move to the 15 heaviest animal, we can see here from the chart, we have the African elephant at the top, which has the body weight of more than 60,000 kilograms. And we can see at the bottom, we have the gray seal, which belong to the carnivorous group, which they have body weight of about 85 kilograms. So this shows the distribution of the body weight as opposed to the diet of this animal. So let's move forward to the distribution. So here in the distribution, I have two charts. The first chart shows the data strip distribution, and as we can see here, it is slightly skewed, and we can see here it is almost uniform distributed across the sleep hour that we have here, with the average of about 10 to 12 hours at the average sleep time. And moving to the rapid eye movement, which is abbreviated as REM, the distribution here is heavily right skewed, with most of the animal having the REM between zero point 0.5 up to 2 hours. So this tells us that this is very clustered to the left, which show that most of the animal, they have almost the consistent numbers of rapid eye movement. So moving forward to the comparison group, I have created this box plot to show like the consistency of the sleep time between different kind of diets in these mammals. As we can see here, we have a very short box plot here, which belong to the omnivorous, which tells us that most of the species in this group of diet, they have similar sleep time, which do not vary large as compared to other groups like insect. As we can see here, the width is very large, which show the variation of sleep time in this fish, in this dietary group is very high. And also, if we look at the second chart here before, it also tells us like we can see here for the omnivores, we have a hint which shows a lot of species, they have uh, far less similar sleep time as compared to the other group. And the worst one here is the insect here, which shows there is a very large variation of sleep hours between this dietary group. So moving forward into the relationship, I have plotted um, the data points of these animals and their total sleep hours against their weight. So I have normalized it in log 10 scale in order to produce a straight line here, which give us a negative slope. And from this line here with a negative slope, it quite show us like as the body weight increase, the number of sleeping hour decrease, and this can be verified by the data. Like we can see here at the far right side, we have the African elephant, and it has a weight of almost 6,000, and it belongs to the group of the um, herbivores, and we can see that it has the less sleepy total hours. The same to the little brown bat. The body weight is less than a kilogram, and the total sleep hours is almost 20 hours. So the body weight, it kind of dictates to us how the sleep hour varies. As we can see, the heaviest species, they tend to have the less sleep hours, and the lightest species, they tend to have a very high sleep hours. So moving forward into the conservation status, I have grouped the data into 6 groups, and we have the least concern here, abbreviated as LC. We have vulnerable group as VU, and also endangered group. And as you can see from these three charts here, which are the key concern here, for the least concern, it is normally clustered across the different sleep hours, and we can see like for the animal which are least concerned, they tend to have a very high distributed and a normally distributed sleep hour duration. And speaking of the endangered animal, this show a quite interesting shape, which is uh, which is more clustered to the right and a little bit to the left, which give us two kind of of stories. And also, if we look at the vulnerable animal, we can see the right, they are more clustered to the left side, which means they tend to sleep less. So this tells us like also the conservation status also dictates how mammal sleep. The same case to the domesticated animal, which is more uh, clustered to the left, which is the less number of sleep hours. So to sum up with my analysis result, it did show us that body weight, as the body weight increases, it tends to make the sleep hours lesser. And also, we have also shown that the diets tend also to dictate the sleep behavior and consistency to some of the animals. As we have saw the omnivorous group, they tended to have a very consistent sleep hour duration as compared to other groups like insects, which tend to have a very varying wide range of sleep hour duration. And also for the conservation status, the animal which are in danger, they tend to sleep less as compared to the animal which are not vulnerable, which are not in danger. They tend to be free and sleep well. So thank you so much for listening and have a great holiday.